Just at your YouTube. I was going to give myself a shout out to my YouTube channel. That's all right.
Okay, so I am adding the project folder that we were working with last time, which was this AR without Rails folder. And I'll pull up the file in which we started doing some work and just quickly review what we were doing, which was at the top of all of the files that we're working with today. We've got a require relative to the ar.rb file. It's the one that was pre-written that includes active record and loads up a bunch of models from the models folder. So that's just going to be part of each one of the files. We're working specifically in all of our examples with the customer model. And later on today, we'll work with the province model as well. Currently, the customer model is empty, just to show the fact that with just the name and a inheritance on active record base, active record will go to the database. It will look for a database table, which it'll take the class name, it'll lowercase the name and pluralize it. And Rails tries its best to properly pluralize words. So if the word ends in like an IES, it usually gets it correct. It knows some special cases for certain things that it might not know, like geese or moose or something like that. There is an inflections file where you can teach Rails sort of how to pluralize special cases if you really need one of those special cases as a database table. And as of last time, we were just starting to see how to interact with the customers table, which our customer object maps to, by doing active record queries that then will write the SQL for us. So we did a customer, and that's going to the capital C customer.count, and that did a select count star. We did a customer.first, and behind the scenes that did a select star from customers. It ordered on the ID and it limited to 1. And then we saw that we could do things like inspect the customer or even pretty print the customer to get details out about the object that's retrieved. The other thing I can do here is I can put first customer.class just to show that when we get that object back, it's going to be an object of type customer. So go into the folder, Ruby AR read. And so that's a line 11 here is returning customer, because that was the class. And then specifically when we inspected, we see that the very first customer is a customer that has an ID of 498, a name, an address, a city. All of those are properties of customer. None of those properties are defined here. There's no getters or setters defined. That's all written for us by active record based on convention. So as long as the database contains a customers table, active record will do the work of figuring out what properties are required for the object. All right, let's do a little bit more. If I wanted to find all of the customers, and remember there's 10,000 plus customers here, I could do customer.all. This would be all customers, I guess. Better naming conventions. You would initially assume that right here on line 14, the database would be invoked and a select star from customers would fire off. But active record tries to be smart about fetching data, especially for expensive operations. This would be a very expensive operation, right? We go get 10,000 rows, and then we would have to construct 10,000 objects of type customer and put them into an array. What if we don't even use that data? Or what if we just use, what if we really were just trying again to get the count of the customers and we're just going about it a bit long? So if I put all, not customers dot count here, well, I've never actually used any of those 10,000 rows. If I run this script, you'll see that the query that was invoked was not a select star to find all 10,000 customers. Active Record optimized it to what I actually wanted, which is just the count. So the SQL commands that are triggered by interacting with Active Record are lazy loaded. And by that I mean they're like put off until the last possible moment. And so only when you actually go and use or touch the data will Rails or Active Record go and fetch the data for you. So if I wanted to get 10 customers, I could do limit 10. That's not going to trigger the request for the data. But then if I go to those customers and I do an each on them, customer, and I puts out the customer's name, and I puts out the customer's address, and I puts out the customer's city, and then I puts out 10 customers.class. The SQL that will be invoked is going to be a select star from customers limit 10, something along the lines of that. It won't be invoked though until here when I actually start looping over the customers. And then when we look at the class of what comes back to us, even though we treat it as if it's an array, we call each on it, we could index into it with square braces, we can treat that thing as if it is an array. It's not actually an array, and that's how the lazy loading happens, right? So when you go to customer.limit and you get back this 10 customers, that's not giving you an array back, it's giving you something called an active record relation back. And it's that active record relation which is going to sort of look like and act like an array, but only trigger the required SQL when the data is needed. So if I go and run this code now, see I've printed out that data about the different people. Probably be a little bit more helpful if I had an extra put statement there to space the people out. So there's a bunch of people that are being printed out from my request, and you can see here the object is of type customer active record relation. That's the type of this 10 customers. Everything else we do with Active Record mirrors what you would do in SQL. So you can always sort of think in SQL first and sort of deconstruct what you need to do in Active Record. When you're first learning it, you'll make that kind of translation, and the longer you work with Active Record, you'll eventually just start thinking and using it in Active Record terms. One of the side effects is Rails will be very good about writing efficient SQL for you, delaying the SQL if it needs to. The queries are really well written. You personally, though, if you spend a lot of time writing Rails, will forget SQL, right? Because you won't be practicing typing it anymore. So I used to be a lot better at SQL before I started doing Rails. I just haven't used SQL as much as I did in the past because I have something like Active Record handling it for me. So now when it comes to writing raw SQL, when I'm using something other than Ruby, I'm like, oh, I'm a little bit lost, right? I know my basic select statements and whatnot, but it's been a long time since I've written, like, say, complicated join statements and whatnot. So yeah, there's an argument to be made that it could make you a little bit lazy, but it also makes me very efficient, and we'll see later on in the course that allows us to do things like navigate complex relationships, like many-to-many, one-to-many relationships, without having to think about foreign keys at all. It links the relationships up for us. Similar to what someone pointed out is what Microsoft's link technology does, the ability to sort of navigate from associated records to other associated records. So let's build something up. Let's imagine in our mind a fairly complex query in terms of SQL. We're selecting from customers. We're going to add a where clause, and we're going to say where the city equals Winnipeg. We're going to, maybe let's put an and on that as well. and name like. So we want Winnipeggers whose names begin with the letter A. We would like those Winnipeggers ordered by their name, and we will limit the result set to 3. At the end of the day, not a super hard thing to write ourselves in SQL, but there's a lot of opportunity for typos, in that process, and it's sort of nice to know that when we use Active Record, all of that gets written for us. And so here's how we would compose this in Active Record. So I'll say like 3 Winnipeggers equals. Again, we go to our customer object. And we're going to do a where, and we're going to say where city Winnipeg. So when it's a simple where we're matching for the exact match, so all customers that have a city with an exact match to Winnipeg, inside of the where parentheses, we just say city or any column name, colon, and then what we want it to match to. So city is of type string, so I just, passing in a string. If I was checking for something that was, a numeric value, I could say, whatever numeric column, colon, and then the number that I wanted an exact match to. That works. To make ands, we just chain another where. And you'll see what I'm doing is I am chaining, rather than chaining on one big long line, we tend to chain with the dots aligned in Ruby. And so here, I've got something a little bit more complicated. It's a like statement. So instead of it being an exact match, I can also pass to the where clause just a portion of the SQL string where I just writing SQL. And so that would be like this stuff right here. So if I copied and pasted that into a string and paste that in. Oops, didn't get quite my double quote at the front. Got one extra one at the end. So I've now done this part. I can further order by the name or whatever column I wish to order by, or multiple columns, and I can chain a limit on as well. And we have now sort of recreated that query in terms of a bunch of separate chained methods. So what comes back after each method here is another one of those active record relations. So when we do customer.where, we get an active record relation back. We call another .where on that active record relation. We get another active relation back. We're sort of building things by chaining on. The SQL is never invoked until we actually make use of the data. In this case, we haven't made use of the data at all, so that SQL will never even run. If I wanted it to run, I could do something like either pull out one or more of the customers from this returned collection, and then the SQL would trigger. So if I go to 3 Winnipeggers.each do, and I get my customer, and I puts out the customer name, and I puts out customer city, which should be Winnipeg for all of them. I should be able to, sorry, I'll mark this down so I don't block it. And there's our 3 different Winnipeggers. Ainsley Walls, Alan Montgomery, and Amity Tate, all Winnipeggers. And if we scrolled up, we would also see the SQL that was executed there. There's our select statement, which looks similar to the one that I crafted above. You can see it has question marks in place, so it's like parameterized, and then the parameters that are actually being slotted in are mentioned afterwards. The fact that the city is Winnipeg and the limit is 3. Winnipeg is put in for that first question mark, and the limit number is put in there. If we wanted to further refine this collection, we could do so, right? So even though I've gone and fired off that SQL and got some results back, I could further refine that. I could say, okay, well, I also just want, so say W, just because I'm going to throw this one away. But I'll say 3 Winnipeggers dot, and I can put another where clause, and I could say, well, now I also just want to make sure that the name ends in the letter E. And, oh, I need double quotes around this because there's single quotes inside of it. And then if I take this same statement here and I copy and paste it down below and just change this to a W. I've got a different set of people. Their names begin in the letter A and end in the letter E. So your active record relation is never sort of closed. You can always go back, even after accessing the data associated with it, you can go back and chain on more information, more where clauses, different order clauses, that kind of thing to sort of continue to refine your data set. The other thing we tend to do, especially in a Rails application, when you're pulling up a single record, you'll have a route which will be called a member route, and all member routes mention the thing that you're trying to load up by ID. So you might, if you have a URL to load up a particular customer, it might look like domain/customers/12, meaning like load up customer 12, or /customers/498. Find the customer that has a primary key of 498. Inside your controller, you would have something along the lines of customer, and you just have a find statement, and you find by ID. That works. That will find a specific customer for you. What also works is a array. So I could be like, well, give me customer 498, customer 8000, and customer 9001. That will give you a collection of customers with those IDs. You could also do customers.find, and you can do a range, like give me the customers from 498 to 532. I won't bother interacting with any of those. They'll just do the thing that we want them to do. And in fact, because I'm not using the data, none of those will actually trigger any SQL. The last thing we might want to do is we sometimes want to find a single record and not by ID. So ID will always give us back a single record or one record for all of the IDs that we've asked for. But sometimes I want like a single thing back. Like if I know someone's email address, so if I go look back here, here's an email address that is in the database. Did that copy? I don't know. Yeah. And so, ooh, shouldn't have that still up. I can find by, well, there's two ways of doing it. I could do like customer equals customer.where, and then I could set up the email address to be like whatever email address that I want to query into. But that'll give me back a collection. And so if I wanted just a single customer, I would have to like do a dot first on that. Or just, I have to keep in mind that where always returns a collection. So instead, we have a special method called find by, and I can say find by ID, and I could do the same query, and that's just going to return a single match. And if it was something that isn't you know, a unique thing, it'll just find the first occurrence of that as a match. So it does a limit 1 for you, and then just returns the object, not the collection. So in this case, returns a collection even if there is only one match. Returns a customer object or nil if no match. It's not as common as it used to be, but there's another way of interacting with find by, which is with the magic methods. So you could say find by email. There is no find by email method in Active Record. And yet I can still do a customer find by email and pass it an email. What Active Record does is it makes use of a feature of Ruby in that when you call a method on an object, if that doesn't exist, there's a hook that you can hook into, and it's called method missing. And so what Active Record does here is if you say find by email, the method missing hook will be invoked. It'll do a regular expression. It'll notice that you're starting your method by the words find by and you're ending it in email. It'll be like, oh, you want the email column, and it'll just invoke a magic method for you that it will create at runtime on the fly. And it actually is fairly efficient at doing that. Method missing is like a very integral part of how the Ruby language works, and it's how a lot of the fancy sort of meta programming that puts the magic into Rails happens. So there's these kind of special methods that get invoked in Rails that don't actually exist until runtime, like this one. I find that I like to use this version of it better because it's less magical. So the less amount of magic, probably the better, especially when you're new to a framework. But this would work and it would do the same thing. And that's all I really got to say about the R until we come back at the end of the lecture and look a little bit at association. So we'll look at how we can go and read related resources. So after I do create, update, and delete, we'll look at a relationship between customers and provinces, in that a customer can belong to a province, and a province can have many customers, and the customer has a foreign key, and we'll see how we can read data back that belongs to those relationships. So we could find a province object and ask that object for all of its customers, or we could find a customer object and ask it for its province object without having to directly manipulate the foreign key itself. Any questions about finding? The one aspect that I didn't really mention is older versions of Active Record didn't support OR. So when you chain two wheres together, you automatically get an AND. We do have an OR now. That was a few versions ago they introduced an OR. It works a little bit different. You can't just chain it on. OR takes as its argument an Active Record relation. So you could pass a relation to OR something, to OR two relationships together is effectively what happens. For docs on all this, we have our Rails guides. And so guides.rubyonrails.org has a number of model guides from basics to validations, which we'll look at in a moment, associations, query interface. The query interface is sort of where most of the advanced query stuff exists. All right, let's create a new file for creating. So I'm going to touch a file here that I call ar_create.rb, and I will open it up inside of my editor, and I will get prepared to run it. And at the top of that file, like the other files, I need to require relative to AR.RB. There's a small gotcha with creation. It's not a big deal conceptually, but it's something that you have to keep in mind, which is that you're working with this object relational mapper, which makes it look like you're just dealing with objects. But at the end of the day, there is a database that when you create, you need to persist to, and that, for some of the ways that we create objects, doesn't happen automatically. So you can create a new customer object, fill it with data, that will exist in memory, but until you call .save on it, it won't be persisted. The actual create statement, the SQL create statement, won't be invoked until we ask it to be. So, if I create Wally Glutton here, I could just straight up do a customer.new. If I puts out Wally Glutton.inspect, that's going to show me just an empty customer. Everything is nil. This has not been persisted in any way to the database. So I didn't just add a blank row to my database. It just didn't affect the database at all. It brought it into existence in terms of memory, and then I didn't do anything with it, so that memory disappeared at the end of the program. Once that object exists, though, I could do things like set the name, or really set any of the properties. So let's say the address is like 160 Princess Street. I could set a email address. Now when I go and inspect the object, we'll see that some of the properties have values. Oops, I didn't quite catch the save there. There we are. So we'll see that some of the properties have values, but still we haven't actually persisted to the database. So here's that first inspect, everything's nil. The second inspect, we have a name and an address set, as well as an email address set. Still a bunch of nils. It's pretty easy to tell when something hasn't yet been persisted to the database because you'll typically see no ID, because that's the database primary key, and you'll see no created and updated at. Those are the database timestamps. So how do we actually get this thing to persist? Well, we get it to persist by invoking a .save on it. And then if a third time here I try to inspect my element, it'll look a little bit different this third pass. So third time through, you can see an insert into statement is being executed. That is the creation of the new row. We haven't brought in any concept of validations yet. So inside my customer object, it's still empty. So there's nothing stopping this data from getting into the database. Once we bring validations into the picture, the create statement or the insert statement is only going to be invoked if the object is valid according to the validation statements that we define. But in this case, there's no validation set up here, and so our Wally Glutton customer gets saved to the database, and the final inspect looks a little different than the others in that the ID is set. So this is the actual ID of that new customer in the database, and the created at and updated at values are set to the same time, which is now, but probably Greenwich Mean Time or something like that. That's one way of going about it. There's a few other shortcuts that we can use. So I'll make a daisy button. We can use new, and we could pass key value pairs to it directly. Just like before, that's not going to be persisted until a later time when we call .save on Daisy Glutton. Another way of handling this would be there's a method that does it sort of all in one go. It will create the object in memory, but it will also persist the object to the database as long as it's valid, and that's the create statement. So I'm just overwriting this Daisy Glutton with a whole new one, and I'm saying, well, Daisy gets a name and an address and a city and an email. And that will persist to the database because, well, as long as it's valid. In this case, we still have no validations. We'll get into that in a moment. But so we will get a Daisy Glutton. The other thing that's slightly problematic about my script is that now every time I run it, I'm going to get a brand new Wally Glutton added to the database over and over because there's nothing stopping duplicate entries from getting into the database either. But I'll be okay with that for now. So let's run this script. You can see here's the insert statement for Daisy Glutton. And if we had inspected that Daisy Glutton object, we would have seen an ID and the timestamps would have been in there as well. I'll put a few comments in here. This would create the customer object. Wouldn't be persisted to the DB until a save was called. This will create the customer object. Save that to the DB as validations. Okay, any questions about that? 3 slightly different ways. So either just creating a brand new object, setting some properties and calling save, using new and then passing key value pairs, and then we didn't show that, but I would have had to call save for this to actually work, or create, which does it all in one go. Save is going to return true or false. True if it actually works. That means validation's passed and the save was successful. Create returns the object itself. For any given object, we can also call .valid question mark on it, and it will tell us up front if that object is valid according to any validations that might be set on it, which means that we can now go and maybe add some validations. So I said that there was a problem here in that we are adding multiple Wallies and Daisies to the database because there's nothing preventing unique duplicate entries into the database. I'm going to go back and I'm going to make sure that I give Wally a city. No, I'll just remove Daisy's city. Simplify things. I'm going to go to the customer object, and this is where we add validations. So if you think back to WebDev 2 when we were doing validations on really anything that was about to end up in the database, we hand coded those things. There was like series of if statements and Boolean operators. We don't need to do that in terms of Active Record because we can declaratively define what makes a valid customer versus what doesn't. So I can say validates, and maybe in this case, a valid customer is one where like the name and the address and the email address are all present. Careful on the order of the colons here. The first 3 are all symbols with the colon on the left-hand side. mentioning that this is like the name column, the address column, and the email column, but the validator itself is a key value pair, so it has the colon on the right-hand side, so we're saying presence true. So those are all required fields now, and it'll test for not only nil, but empty string as well. So if you try to set the name to an empty string, even though it's a string, an empty string is still considered to be not present. And so if I also want to prevent, duplicate entries, I might assume that an email address is something that cannot be duplicated. So I could say validates that the email address has a uniqueness of true. Yeah.
Does uniqueness imply presence be true also?
That I don't know. We'll play around with that a little bit. I almost just like as a matter of course always put the unique thing up in my presence list, but I don't know if that is required. Let's get rid of that and play around with it. One way to play around with this kind of stuff is instead of just writing code in a file, which we'll do in a moment, from my command prompt, I can run IRB, which is that interactive Ruby prompt, and I can do a require relative from there of that ar.rb file, and now I can do things with the database. So I could go and create a new customer, C customer create. I can give this customer a name, and I can give this customer an address, test, and I can give this customer an email address. I'll initially leave that off and see what happens. See. That persisted. So you need them both. Oh, so that they're both with missing email? There you go. So it prevented the second one. So it's like, it's even unique in when it's not there. Yeah. So there's two, yeah. It's doing the right thing, but not really what I would be expecting as expected behavior, which means we want to provide both up there. Let's write a little bit more code here in the create statement then, or even just run the create file again, and we should see that Daisy and Wally are no longer saved to the database, and we can ask why. So here I could say something like if Daisy button.valid question mark puts this object is valid. That should never run because there should be at least one validation, the email one, failing. And so I'm going to put out Daisy errors.messages, which is where I know that the error messages go. This has validation issues. Another thing I could have done up here at the Wally level is I could have put that kind of if statement around the .save, because if the validations failed, the save would return false. But here, if Daisy is valid, puts out this object is valid, otherwise it'll tell us what's wrong with that object. So I'll run that ar.create or ar create. And it tells me this customer has validation issues, email has already been taken. If I make it so that there's more than one issue, so I remove the address here, and I run it again. Well, the address was a required field by way of the validations. So now address can't be blank and email has already been taken. if I remove the email as well and do the same thing, we see that email cannot be blank and it's already been taken, meaning that's that blank one that's in there, and that the address can't be blank. So what we get back when we go to errors.messages is a hash where the keys are the columns and the values are the array of things that are wrong with that particular column. And of course, we only need to look there, if the thing was not valid to begin with. If it was valid, there won't be any error messages because the thing would have been persisted. And so these are what we could use, if we're accepting data by way of a form. The user puts some information in, they forget one of the fields, or they put in an email address that isn't unique. On the returned message, we could prompt them and say, sorry, we couldn't save your entry because, and we could sort of list, that the email address can't be blank and that the email can't be blank and it's already taken. We could sort of enumerate the reasons why a save didn't occur to the user of our web application by way of using this error messages. There's a whole bunch of pre-built validations similar to the two that we've used. We can see all those in the Rails guides. There's a whole validations guide. We used presence so far and uniqueness. There's the opposite of presence, which is absence. Numericality is quite powerful, like to specify that something is a number. You can further refine numericality and say it has to be a number and it has to be an integer, or it has to be a number and it has to be greater than some value or less than some value or fall within a range of values. There's a lot that you can do. So for example, here they're setting up points, numericality true, games played, numericality true, but also only an integer. There are validators for passing a regular expression test. So format will test for, does this thing match a particular regular expression? Inclusion matches to see if the thing that's supplied is included in a provided list. Length, well, is this thing less than a particular length as a string, greater than? You can do all sorts of length restrictions. And if one or more of the built-in validations don't work, you can write your own custom validators. Yeah. The sanitization is happening for us. So we don't need to worry about sanitization as long as when we are creating, when we get into working with Active Record in Rails, I'll show us how to properly create parameterized queries. So as long as we're using parameterized queries when we insert data into the database, the sanitization is going to happen for us. So yeah, that's basically the gist of validations. And as I said, you can create your own custom validators just by creating a method that is going to look at whatever properties you're interested in and return a true or a false statement saying, yeah, this is valid according to a custom rule, or this is not valid according to a custom rule. I think that's this one here, is it? Yeah, so you create your own validators by way of extending active model validator. You build a validate method within it, and then you can validates within your object. So you create a little tiny utility class to build up custom validators. And that is create. And so next up is update and delete. They sort of go hand in hand because of the fact that for both of them, you need to first gather a record or collection of records that you want to either update or delete. You have to have something to work upon for both update and delete. I'm going to create a new called update delete.rb. I'll open it up. And it will require relative ar.rb. so that we get access to Active Record and our various models. So let's go fetch a customer. We'll say customer equals customer.find customer 9000. Let's take a look at that customer. We'll do a Ruby AR update. So there's customer 9000. It's Iris Giles, a Winnipegger living on Blandit Avenue. And let's just say we want to update this customer. Updates are going to be subject to the same validations as creations, so we can't invalidate an object and then save it, except for when we can. So there are a few exceptions where there will be special methods that are considered dangerous and they skip the validation step. So for example, if you want to bulk update hundreds of thousands of records, you probably don't want to trigger off hundreds of thousands of separate update statements. If you wanted the validations to trigger, then that's how you would do it, because you would validate every single one. If you want to do a bulk update, which will equivalent sort of SQL be a single SQL update statement that sort of mass updates a whole slew of records, the validations are skipped. So it's more dangerous to do it in that way, but sometimes for efficiency's sake, we would want to do it in that way. I'll show us both. But first, I'll just update this one single customer. So if I was to invalidate this customer, so customer.name, just blank out the name. If I do a save on that customer, so if customer.save, what's save was successful, that should never execute. Puts error. And then I can put out customer.errors.messages. Take a look at that. Oh, thank you. Successful. If I run this now, name can't be blank. So I pulled a customer object, I manipulated it, I tried to save it, no go. Same customer object, take that name. Iris just got married to someone named Mr. Integer. So Iris Integer. And we can use the same statement there to check it out. So the first one should fail, the second one should succeed. And you can see the update statement firing off right there. You can see the name is being set to a question mark. That's what the name is. And you can see the updated at timestamp is being automatically updated for us with the current time. And then there's a where clause to target that particular customer. So we happen to just change one property there. We could have changed all of the properties. As long as we kept the object valid, as long as we passed all of these validations, then that would have been fine. The one thing I didn't mention about validation that is worth mentioning is that these validations are all happening in our Ruby code. They are not database level constraints. If you are creating an application which you expect to be like a production, robust application where data integrity is super important, of course you're going to want to add database level constraints as well to match those things. One of the examples that people often say as to why you would want to have a database level constraint as an extra guard is, for example, this uniqueness. If we're just testing uniqueness at a code level, you end up in a situation which is called a race condition. You may have heard that term before. You'd be like, oh, this sets up a race condition. What a race condition is like two paths of code execution are literally in a race. And depending on which one executes first, you might end up with bad data in your database. So let's just imagine that there's two customers signing up for our site. One is John Smith at gmail.com, and the other one is John, Womith at gmail.com. But this John Womith typos his name, and they both try to sign up as John Smith. There is a race condition which could happen in that if this person submitted their request a little bit before this person, the database would be queried. It'd be like, oh, there's no jsmith@gmail.com in the database yet. Meanwhile, this person has now put their request in and it's in that race. And maybe it gets spun off to a different processor and it hits, and it also does that test. Oh, there's no JSmiths in the database. You now have two customers who both think that they have the right to write to the database, and you will get two jsmiths@gmail.com written to your database because of that effect of a race condition that's happening because there's two separate executions that are happening on different parts of your application. So it's a danger. It'll work for a lot of cases, but it's not foolproof, which is why when we're working with the database, we use things like database level constraints. They're there for a reason. We always want to leverage what the database has to offer. When we talk about migrations in Rails, which is how you create new tables and new columns, we'll see that there are ways to, when we build our tables, the data that we're working right now came to us pre-built, but when we create tables, we can add those database level constraints. Sometimes Rails adds them for us. So for example, when we set up foreign keys, Rails will add foreign key constraints automatically for us, but we can also ask for other kinds of constraints at the database level because those are important for data integrity, and there are race conditions that will happen when you're working at a code level validation that will never happen at a database level validation. The database is not subject to those same kind of race conditions because it does things like transaction locks and things like that. Okay, that was a bit of a side note, but I think it's important to talk about those things. Back here over to update and delete. This was updating a single customer. We can also update collections of customers. And so if I go and get my Winnipeggers, that's going to give me all the Winnipeggers. I can update all of the Winnipeggers in two ways. If I want validations, so with validations, I could go to my collection of Winnipeggers and I could pull out each Winnipegger, and I could go to that Winnipegger and update. Oh yeah, the other thing I can do is I can just call update instead of dot thing, and that way I can update multiple things at the same time. But I'll just do dot city because I'm only updating one thing. I'm going to change it to Winterpeg from Winnipeg. That's going to fire off however many Winnipeggers we have in a database. I think there's 58 of them or something like that. That's going to fire off one update statement for every single one of those customers, and it will first try to perform the validation. So if, for example, we accidentally also nilled out all of those Winnipegger names, none of those updates would actually happen. The validation would catch that. So if I tried to run this, did that do it? Oh, because I didn't even call save on it. That's the final piece of the puzzle. that's one way of doing it. Now that I am using multiples, another way of doing that same thing would have been just to say update name, nil, city, Winterpeg, and that would do these three things. So the dot update performs the save after mutating the data. Regardless, this should fail. Whole bunch of attempted transactions with rollbacks you can see happening there because the validation didn't pass. But what if I was feeling confident and I had a giant set of data that I wanted to update? I wanted it all happen with a single update statement. Maybe I'd poked around at the data, ensured that it was, valid, and I wasn't worried about the validations running. Well, I could go to Winnipeggers and I could say update all, and I could change their city from Winnipeg to Winterpeg, and this will actually do the thing. And it'll do the thing not by invoking one update statement for every object. It just does this one line here. Because we can do that with SQL, right? We just say update, set customer city, provide the where clause. Any row that matches city where it's Winnipeg will have that city updated to Winterpeg. And so we've gone and mass updated all in one go. How do we know these kind of distinctions, like when validations will be skipped or when they won't be? If you want the real nitty-gritty ins and outs of how Rails operates, you go to the Rails API. So the Rails guides give you like the high level, this is a tutorial of how these things work. The Rails API is more just like API docs. The API is at api.rubyonrails.org. You can sort of navigate by a tree structure, or you can just search, right? So I can just search for update all, click on that, and you can see here, it does not instantiate the involved models and does not trigger active record callbacks or validations. So it's a bit of a dangerous operation, but sometimes you would want that to happen, usually for sort of speed or efficiency purposes. I find that the API is not too helpful when you're new to Rails because it's sort of like a dictionary. You need to know what you want to look up before you can find it, right? Because you're searching for various like method names. So when you're new to Rails, the guides are much more helpful because they sort of walk you through what's available. Once you know what's available and you need targeted reference on a particular thing, that's when I find the APIs more helpful. And then just like updating, deletion works in that you need a thing or a collection of things to actually delete. And so if I go to a customer and I find, say, customer like 8005, and I save that to letter C here, I can call c.destroy, and that will delete that customer. And there is a customer destroy operation. This one does not check validations because it doesn't matter. You're just about to delete that data. It'll check references. Yeah. And those will also be protected by a foreign key constraint at the database level that Rails will put into place for us. And don't run this, but you could even do like this, right? And that would just
One person's gonna run it.
Yeah, I can be that one person. Exactly. So yeah, here we can run it. Oh, it died before that because there is no customer. 8005. What? Okay,
It
well.
didn't say it didn't necessarily.
Oh, yeah. Rubocop's so slow. There. And look at it. It's calling one per.
That's super slow.
Yeah. So there's also ways to do bulk. I think there is. I think there's like a drop or truncate, or there's a way to do a delete which isn't 10. I think there's 10,000 records here. So there's a way to do it that isn't 10,000 separate delete froms. What that is. Yes, he's going to be here within moments. I'm like, I didn't do it. Is it delete all? Is that the different one?
Just drop their table and recreate it.
Yeah, so delete all is the more efficient. Destroy uses callback, so it'll check for things like foreign key constraints, and it will, that's why it's doing this, right? Because if you had foreign key constraints, some of the deletes should fail, but not all of them should fail, right? Typically. Whereas if you do delete all, it's just going to skip that, and it's just going to do a single delete statement, and then we wouldn't be sitting here waiting for 10,000 delete operations to occur. Yeah, let's take a little bit of a break, and when we come back, I will bring my database back into existence, and we will look at associations. So I brought my database back into existence just with Git. I just did a Git checkout to grab the database as it exists up on GitHub, so that I didn't have all of my tables dropped for my customers. Let's create a new file here though. Touch associations .rb. Require relative ar.rb. Associations are one of those places where there are some conventions, some naming conventions, but there's also some requirements that you're going to have to code into your two classes or into your associated classes. So it's not enough just to rely on the conventions here, but the conventions are as follows. Foreign keys are named after the table they associate to. So if you have, let's just say we have a relationship where a customer belongs to a province and a province has many customers. In the customers table, there would be a province ID foreign key. Not a province's ID, but a province ID. And because it's referencing a single province. So when you have a one-to-many, which is what we're setting up here, the foreign key goes on the many side of the relationship. The foreign key goes on the customers table, allowing each customer to be associated with a single province. So, and the naming convention can be overridden, but this is default what the active record will look for. Beyond just that though, it's not enough to have a column named in this manner. We have to, within the customer object and the province object, have a little bit of setup code. And that was in the code already when we first started working, but I had us delete it. The right stuff will already be in the province. But what we need to do is we need to go back into the customer inside of the model folder and mention that a customer belongs to a province singular. So again, even though the table is called provinces, it's really important that we don't pluralize this here. pluralization and singularization is one of those places where it's very important to get them right. And usually by saying things aloud, you can allow what sort of sounds right in English grammar sort of guide you. So here we're saying a customer belongs to province. That sounds grammatically correct. It would be odd to say a customer belongs to provinces. At least it sounds odd to me. Same thing goes vice versa. Over here on a province has many customers. This should already be in your province table. And again, it probably would sound odd to say a province has many customer. So usually you can just say things aloud and you can know which needs to be the plural and which needs to be the singular, but it won't work if you get it wrong. And by setting up this relationship, by specifying that a customer belongs to a province, this is indicating this table or the associated table has a province ID foreign key. And now, from this associations file, I can load up customers by way of provinces, and I can load up a province by way of a customer. So because I have both sides of this relationship, a belongs to province and a has many customers, I can load one through the other here. First, I'll show what you don't want to do. People that are new to Rails and Active Record, but have done a bunch of database work, will be tempted to micromanage or manipulate the foreign keys. So someone like assuming that we wanted to find all the customers that lived in Alberta, you might be tempted to go to the province and find by the name Alberta, and then try to find the Albertans by going to the customer where province ID alberta.id. That would work. And then we could like puts out albertans.count. Oh, I need to run this Ruby associations. That works. We see that there's 1,111. But instead of doing that, we can just go to alberta.customers.count, and that's this chaining that we set up. So because we said we have many or has many customers, we can now on a province object just go to .customers, and that will lead us to the associated collection of customers, and the foreign key stuff is handled for us. So if we run this code, it's going to do exactly what it did before and load up 1,011 customers for us without having to micromanage the foreign key. Same thing goes for the other direction. And so by the other direction, I mean going from a customer and finding out which province that customer belongs to, which single province. So if I get a customer and just do it by customer.first, again, what I don't want to do to find out that customer's province is to go to the province and like find based on the customer's province ID. That would work, but instead I can just puts out or utilize customer.province. That gets me to the object, and I could even chain directly to that province's name. And so first customer is Christopher Hartman. Where does Christopher Hartman live? Christopher Hartman lives in Alberta. And the reason we can do customer.province is because of the fact that we set up belongs to province at the class level. It wouldn't work otherwise. So there's nothing technically wrong with making use of the foreign keys, but you don't need to. You've got helper methods that allow you to chain to those things yourself. And you could chain even further. It's like, okay, I want to go and find all the other customers that live in the same province as Christopher Hartman. I could go to customer.province.customers, and that would find all of the customers that live in the same province as this customer. So that's another way of getting at the Albertans without even really caring or knowing that it is Alberta. And then you could do like ridiculous things, like you could go to the customer's province collection of customers and then find the last one and ask for their name. It's Bo Green. Probably don't want to write code like that. It's sort of a windy maze to figure out what's actually happening, but you could, right? So try to keep those kind of long, winding requests in check. How long you can go. And then again, if you were to be chaining that long, it's usually best to make it more readable by lining up the dots. You don't like that? I find it just so nice and readable. To know that the last dot name belongs to that thing. Yeah, I agree. I agree with you there. Because then it looks like, what is this last being called upon? Yeah. So like that. We can do this, but we really shouldn't. There you go. Like this? Yeah, there you go.
It's still readable.
It's still readable.
It looks good in your code.
Oh, look at Rubocop did not like that, and it moved it on us. So I'll put it back over here. If we go to the guides, I won't demo a many-to-many, but we can look at how they show one in the guide. So if I go to active record associations, we've just looked at a one-to-many. Many-to-many relationships is when we have a join table that sits in between two related sets of data. In the case of the example that they have in the guides, it's this idea of physicians and patients, and a patient can see many physicians, and a physician can have many patients, and they are joined by way of appointments. And so appointments is the join table. It has its own join model. So in this case, you'd have a model called physician, a model called patient, and a model called appointment. Appointment is where the two foreign keys live. It's doing that join. It's allowing the many-to-many relationship. And so it has a physician ID and a patient ID, and then any sort of appointment related data can be added to that as well. So you could have, in this case, they have an appointment date. We can now, by way of our has many and belongs to, you could find a physician, you could look at that physician's first appointment, and then you could look at the collection of patients that, or the one patient that belongs to that first appointment. But you could also go directly from physicians to patients to find out, like, okay, here's a physician, dot patients to find any patient this physician has ever had an appointment with. Or vice versa, you could have a patient and do dot physicians, and you could say, well, any physician that this patient has ever visited by way of an appointment. It's a little bit more complicated in terms of the models. The appointment belongs to two things because it has two foreign keys. So the appointment belongs to a physician and it belongs to a patient. The physician has many appointments. The patient has many appointments. The physician has many patients through appointments. So once you've defined a has many, you can use it to step through to a patient. So here we're giving the ability to go from a physician, and rather than having to go through appointments first, you can go directly from that physician to any patient it's ever had an appointment with by way of the through association. Same thing in the reverse direction. We could find a patient and find its collection of physicians that they've had appointments with if you set up a through on appointments. That makes working with these kind of joins really, really nice, right? You don't have to write any SQL that's actually doing these joins. Your database schemas might end up with a lot of different many-to-manys, one-to-manys, all sorts of different relationships, and you can chain through all of them to find the data that you're looking for, and it becomes quite a joy rather than, what can sometimes happen when you're writing your own SQL is it can become very painful to work with a database that includes a lot of different relationships. Yes, and Rails supports some other ways. This is just one of said ways. This is sort of the Rails appointed way of when we do a has many through. There's like has and belongs to many, which is a different way. I've never used that one, so I don't know the intricacies of it. So you create the table but not a model. Yes. And that would be useful when there's no associated data. With an appointment, you had this appointment date, whereas when we're putting parts and assemblies together, they've decided, okay, we just need 2 foreign keys. We don't even need a primary key. It's just a join table, but no associated data. I've never felt the need or had to use that, but that's how you would set it up. Has and belongs to many parts, has and belongs to many assemblies, and it's based on convention what the name of the table will be. It's the name of the 2 related tables, alphabetized and then separated by underscores. And I think that's all I got for us for today in terms of Active Record. So I will stop the screen cap.